We are going to be graphing relationships, something new in chapter 4. So your learning target is I can graph a discrete or continuous relationship. We first need to talk about some definitions. There are two different types of graphs. These are reversed on your page, so I will reverse those. The first thing is a continuous graph. What a continuous graph is that it is a graph that is connected with lines or curves. When you think about it, it's something that is continuous. It does not stop. If you see the word constant, your graph's going to be constantly, it's almost like a straight line. If you see rows steadily, and please write these in the margin somewhere on your notes, your graph would look something like this. It's rising steadily. There's no break. If it stayed the same, it's not going to go up or down. It's just going to be going straight. And if it drops sharply, it was up and it went boom, dropped very sharply. Those are some examples of continuous graphs. For discrete graphs, I bet you can guess what they are. It's the opposite. It's graphs that have distinct points. Think, discrete dots. It looks like a bunch of dots. Always think back to inequalities. What graphs were continuous? What graphs were discrete? Think about those. Let's take a look at some examples. The first one says, the air temperature increased steadily, so when I see that I know it went like this, for several hours, then remained constant. So then it was constant. At the end of the day, the temperature increased slightly again, so maybe it's not as steep, it's maybe rising like that. Again before, dropping sharply, boom. Choose the graph that best represents this situation. I always draw myself a rough sketch. So I know that it went up, then it was flat, then it went up a little bit more, and then boom. Which graph looks most like this? Well, I would say the graph C does. Anytime you have time is always continuous. Think of a clock. A clock does not stop. It continues on and on and on. These next couple of examples, now we get the opportunity to sketch a graph for each situation, then decide whether it's continuous or discrete. Upper St. Clair is selling t-shirts for the blackout for $5 each. If each shirt if each shirt was sold, the school will get $2 basically per shirt. The cheerleaders have 100 shirts to sell. Well, let's think about what is going on here. We have two different variables. We would have the shirts sold and also the money the cheerleaders would get. Can you sell a half of a shirt? No, you can't. For these, you can only use numbers like 0, 1, 2, 3. Since that's the situation, you know that this is going to be a discrete graph. If you could sell 2 3/4, something like that, then it would be continuous. But since there's only a certain number of shirts sold, that's how you know it's going to be discrete. So let's make ourselves a little graph. We're sketching it. Now, we know that the shirts sold, your Y is always going to be money when you have it. So we're going to have shirts sold And I'm just going to go 1, 2, 3, 4, 5, 6, 7, and then the money made. Now let's think about what we're going to go to. For each shirt, they make $2. So this would go, let's go by twos. 2, 4, 6, 8, 10. So now let's sketch a graph. If they sell one shirt, well, they're going to make $2. If they sell 2 shirts, they're going to make 4. If they sell 3 shirts, they're going to make $6. 6 shirts, or 4 shirts, they're going to make $8. 5 shirts, they're going to make 10 shirts. This is just a rough sketch of a discrete graph. And then we need a title. So let's just title this, The Money Earned from Selling Blackout Shirts. Let's look at number 3. It says a Schwan driver. You know, it's a little truck and has pizza in it and all that good stuff. I used to love Schwan pizza. They enter a street, drive at a constant speed, stop at a red light, and then continuously drive. Well, let's think about what are our 2 variables here. What are the 2 things that are changing? Well, we know that the time is changing, and we know that the speed is changing. Well, since time, we just talked about, time is always continuous, we know this is going to be continuous. Time is always going to be on your x-axis. So we know it's going to be continuous because time is involved. So let's go ahead and let's draw a rough sketch. Let's just title it Schwan Man. Schwan driver. How about route? We just said that the x-axis is always time. So we have time, and then his speed is changing. At time 0, he's entering a street. This right here is 0. So is his speed at 0 if he's entering the street? No, he's driving. So he's like somewhere up here. And he's driving at a constant speed. He stops. So time, I don't want to go straight down because that would be like instantaneous speed. Oh no, that could be bad. So he has to slow down. And now his time, or his speed is at 0. He stops at a light, so time's going on. He stopped at the light. And then he continuously drives. So he's just going to continuously drive. Now let's do the opposite. If I have these here, and it's a little bit hard to see, these are the months. And this here is temperature. Let's write a scenario for it. If I look here, this is July. So I would maybe say the temperature continually rose then, and it continually rose until July. Then, what did it do? It went down, but how could I say that? Then it steadily so what's the opposite of rose? Went down or declined or went down. And then the cycle probably happened again. Now we have our last thing, it's a closure. It says below are 2 graphs that look the same. Note from the axis labels that the first graph shows the velocity of a car as a function of time. Velocity is the same thing as speed. So this is how fast they're going as a function of time. The second one shows the distance the car is from home as a function of time. Describe what someone who observes the car movement would see in each case. Well, in this one, I would maybe say here, the car sped up. Then it drove at a constant rate. constant speed. Then it's sped up again, sped up more. Wow, this looks like an abrupt stop. An abrupt stop at a light. And I would say the light because time went on, so he was stopped for a little bit of time. Then he sped up again. Drove at another constant rate. Maybe he's on the highway. Drove at a constant rate. And then it looked like he stopped. Then, where can I write this? Maybe right here. Then stopped. Let's do this one now. The distance from home. Here, if it's at 0, well, he's probably at home. So maybe they went far away, they went further away from home. So the car went away from home for pizza. Now the distance is the same, so maybe they stayed at the same location. So maybe they stayed at the pizza location. Then they drove further away. Now they got dessert. Drove further from home. How about to get ice cream? To get ice cream. Then the distance from home went back to 0. So they went home. Then went home and stayed there for a little while. And stayed for a little while. Then they drove away again. Now they're far away from home again. Maybe then they went to school. Then they went to school and stayed, because now it's constant again. Stayed. Maybe it was at the social. At the social before returning home again. Because they returned home again. So those are just two different ways. And yours could have been a little bit different. As long as you're talking about they went away from home, they stayed. They went further, they came home. They stayed. They went away from home again. They stayed, and then they went home. Okay, now you should get a joke worksheet, and I want you to please do the joke worksheet.